In this video, we're going to look at modeling 3 examples of sinusoidal functions. Let's look at example 1. The water depth D in meters in a boating marina on a particular day can be modeled by this function, where T is the time elapsed in hours. So I'm going to highlight some important information here. Time in hours since midnight. Write down the depth of the water at midnight. So if it's at midnight, that means that time is equal to 0. So take out your calculators and let's graph this function. In order to graph, make sure that your calculator is in degrees, as always in this course. And then we're going to go into our y is equal to. Now, in order to graph, right now, the window is not really appropriate. What I want us to focus on is that in these types of questions, often they give us the domain. So this should be the window setting that we set for the x. So let me set the window setting from 0 to 24. And now if I look at my graph, I notice that on the top, there's something happening. And if I move a little bit further in the question, I actually see that they give me a range as well. So I'm going to use this information in order to graph my function. So I'm going to go into my y, and my range could be set from 0 to 18. And now I see exactly what I want. Now, I'm looking for time is equal to 0, so that means the x value is equal to 0. So I can do trace 0, and I get that the depth when we're at midnight is 12.5. Part B. The cycle of water depth repeats every t hours. Find the value of t. This question basically is asking for the period, right? The cycle of water repeats every t hours. This means we're looking for our period. So we can use the equation. We know that our value of b is 30. So therefore the period is always going to be 360 divided by b. So my period is going to be 360 divided by 30. So we're going to get that this period is 12, right? So it's going to take 12 hours to repeat one full period. And you could have done that as well by looking at the graph and by looking from a maximum to a maximum, a minimum to a minimum, and you would get that the time between those two would be 12. Now for part C, write down the minimum and maximum depth of water during the day. We can use our calculator and see what is the minimum. So second traced minimum, I go towards the left bound, so I choose a left part of the minimum. Any minimum is absolutely fine. Then to the right, and then I guess. And I get that the minimum, I'm going to write it down here, the minimum is at 8.5 meters. And then I'm going to repeat the same process, but this time for my maximum. And I get that the maximum is at 16.5 meters. Now CII, find the times at which the minimum and maximum depth of water occur during the day. During the day indicates that it's going to be a 24-hour time. Right? So my calculator was already set so that I'm going from 0 to 24. So they're asking me for the times. So this time they're asking me for the x values, right? So I see that I have a maximum twice. I have a maximum at 15 hours. That's the one I have right now on the calculator. And then I can use the calculator to find out the time for the first maximum. We get that that happens at 3 hours. And then we can repeat the same process for the minimum. Or we can use the symmetry, right? There's always a minimum between exactly 2 maximums. So that means exactly between 3 and 15, that's going to be at 9. And then for the last maximum, the last minimum, feel free to use your calculator. Or we know that the next minimum is going to be 12 hours later, right? So that's going to be at 21 or at 9 p.m. Now, when they ask us to draw, we're going to respect all the settings that they gave us, right? So we've already changed our window settings to adapt for this. So we know that our starting point from part A is at 12.5. We're reaching a maximum at 3, and the maximum is 16.5. So somewhere between these two here. And then we're reaching another maximum at 15. So I'm going to put the other maximum here. And then we have a minimum at 9. The minimum is 8.5, so somewhere a little bit down here. And another one at 21. So I'm going to connect these together. And remember, there's symmetry here, so I'm going to try my best to connect these. There we go. And what's super important is when they give you a graph, you need to fill the entire graph, right? So we have our clear points. They're asking us to draw. So this is the most specific, right? It's not just a sketch, it's a drawing. So we have to be specific with our points. Okay, let's go ahead and do question C. A ship with an 8-meter draught is allowed to enter the harbor marina if the depth of the water is greater than 10 meters. Find the time interval, so time interval, before midday in hours and minutes during which the ship is not allowed to enter. Okay. First, we're going to look at when the harbor, the depth is at 10 meters. So 10 meters is this line right here. Now we're only interested in before midday. So that means before 12 o'clock. So automatically everything I have on the right hand side here, I'm not interested. And we are interested in knowing time interval. When you see time interval, it means we're looking for two values, right? So between A and B, for example, we're looking for two values. And the time interval during which the ship is not allowed to enter the marina. Well, if it's smaller than 10, so the depth is smaller than 10, we're not allowed to enter the marina. So we're looking for these 2 points, and between these 2 points, we won't be allowed to enter the marina. So that means that we know what the y value is, 10. So we're going to go into our calculator, we're going to create a new function of 10. And now I see the line here, and I'm looking for my intersection points. So I'm going to have my first curve, second curve. I'm going to have my first intersection point. So the first intersection point is at 10.7 and obviously 10. And then I repeat the same process again for the second intersection point. And this time I move my cursor so I'm closer to the other point that I want. And that's 7.29 and 10. So the time interval when the boat is not allowed to come in would be from 7.29 and then from 10.7. Now for example 2. Example 2, they don't give us a function and we're going to have to create a function by ourselves. So let's read what's happening here. So we have this bridge in Hamburg and this woman finds out that there are 3 sections shown that are each 102 meters long. And she estimates that the vertical distance from the surface of the road to the top of the bridge is 16 meters and that the road is 6 meters above the river. Use this information to model the bridge with sinusoidal functions as shown. So part A, find a sinusoidal model for the bridge, and then hence or otherwise find an estimate for the coordinates of the points F and A. Okay, so for this question, we're going to use all the information that's here and try and make sense of it. The first thing they say is there's 3 sections and each of them are 102 meters long. So the 3 sections that I identify are where the intersection points are, right? So each of these sections is 102 meters. Next, we have the vertical distance from the surface of the road to the top of the bridge is 16. So my road is the black line and the top of my bridge is where the point A would be. And this would be 16 meters. And then the last piece of information we're given is that the road is 6 meters above the river. So the road is this black line and the river is here. So this is 6 meters. Now, in order to be able to create a sinusoidal function, we first need to have some axes. So the y-axis is the easiest one. It should be where we actually start everything. So this is going to be my y-axis. And then you have a choice. You can either have the x-axis be the river itself, or you could have the x-axis be the road. Both are absolutely fine, but they're just going to differ a little bit in the equation that you create. I'm going to use the road as my x-axis. Okay, now there's two sinusoidal functions in here. So I'm going to highlight one of them and then we can focus on one at a time. If I highlight in pink this sinusoidal function, the one on the very top here, right, this is the one I'm going to focus on first to find the equation. Okay, so first we need to look at the y-intercept. The y-intercept is not at a maximum or minimum, so that means that I'm going to be using a sine function. And then since I'm going towards a maximum first, I'm going to have a positive value for A. Okay, let's identify the rest of the information. First, maybe let's talk about this amplitude. So the amplitude is the distance from our maximum to our principal axis. So if we use the information of 16, we know from maximum to minimum, it's 16. So that means that my amplitude is going to be half of that. So my amplitude is going to be 8. If we now focus on the principal axis itself, if we are starting from 0 and then going to the maximum is 16, well, that means that the principal axis is also halfway between them, and that would be 8. And the last piece of information that's important for us is our value of B. So our value of B is 360 over the period. In order to find one period, we remind ourselves that one period can either be from our principal axis, up, down, and back up, or from a maximum to maximum, and then to a minimum to a minimum. So starting at a principal axis, if I go up, down to a minimum, and back to my starting point, this would be the length of one period. Therefore, one period for me is going to be 204, right? So it's double this 102. So we can leave the value of B as a fraction. There's no problem there. So that means that my first curve on top, the pink one, is going to be 8 sine of 360 divided by 204 times x plus 8. And now if we focus on the second curve, which I'm going to highlight in green, the second curve here has the exact same properties in terms of amplitude, period, and principal axis. Also, the y-intercept is a principal axis. The only thing that's different is that it's going towards a negative first. So that means that my function, since it has all the same properties, I can write it the same. But since we're going towards a negative first, that means that the A value should be negative. And now for part B, we're trying to estimate the coordinates of F and A. So let's focus on coordinate F first. Coordinate F is on the principal axis, right? So we know that the y-coordinate of F is going to be our principal axis, which is 8. So I'm going to write down the y-coordinate. And then if we think about the x-coordinate for F, well, that's going to be, we've done 102 and another 102, a full period. So that's going to be our 204. While for the coordinate of A, the coordinate of A is at a maximum. So we know that the maximum happens at 16. And then if we're trying to find what is the x-coordinate, well, we know from F all the way back to the center, it's going to be 102. So if I divide 102 in half, I'm going to get to A. So this is going to be 51. So we're going to do 204 plus 51. So we're going to be at 255. Now the next question is a very traditional question in the IB. They love to have these rotating wheels and asking us to create the equation ourselves. So we have a hamster wheel has a diameter of 16 centimeters. When the hamster runs on the wheel, it rotates through 1 revolution every second. Suppose a point P is marked on the rim of the wheel. Find a sine model for the height of P in centimeters above the ground level after T seconds. Assume that P is initially in the position shown on the diagram. Okay, so we're trying to model this point P rotating around the wheel. Whenever you have these circular motion questions and you need to create a function, my number one tip is to draw a picture right next to the wheel. So that's what I'm going to be doing here. I'm going to be using the ground as my x-axis, and then I'm going to have my y-axis right here. What I like to do is I like to draw some dotted lines to see where the minimum of my wheel is and the maximum of my wheel, right? I'm never going to have a function that passes these yellow lines. And then exactly in the middle of these, I'm going to do a dotted line for my principal axis. I'm going to use the information in the text and put that into the diagram. First, the diameter of the wheel, so from maximum to middle back to minimum, this is 16 centimeters. We have one revolution takes every second, right? So if we do one rotation every second, that means that my period is equal to 1 second, right? One revolution, one rotation per second. And then we also have the information here that the distance from the ground to the start of the wheel is 3 centimeters. So that means that my minimum is going to be at 3, and my maximum is going to be 3 plus 16. So I'm going to have a maximum at 19 here. We're told that point P starts where we can see on the diagram. So point P starts right here on the principal axis, and that makes sense because we are dealing in fact with a sine function. We have the direction of where P is going, right? So we're going to be going towards a maximum first. Because my period is 1 second, I know that 1 second later, I'm going to be back at my starting point. And then if we go with the symmetry of our curve, exactly halfway, so 0.5 seconds. So if I do half a rotation, I'm going to be back to the same height. And between these 2 points, I went towards a maximum. So at 0.25 seconds, I'm going to be at a maximum. And then at 0.75 seconds, I'll be at a minimum. So my graph looks something like this to model the height of P. So now that I have a graph, I can then write the equation of this. So we're going to have H is equal to A sine of B times T plus D. So let's talk about the amplitude. The amplitude, when you're dealing with these circular motion questions, is always equal to the radius of our circle, right? So if we know that the diameter is 16, that means that the radius is 8. And in fact, from our maximum to our principal axis, we see that it does make sense for this to be the radius. So my amplitude is going to be 8. If we talk about the principal axis now, the principal axis, that's the value of D, right? So the principal axis is, starting from the ground, we go 3, and then we have the amplitude of 8. So 3 plus 8, we get that our principal axis is at 11, right? So this is an example here. Like I mentioned in our previous video, it happens very often that these two are different, and that is when we do not start on the ground level. And then the last is our value of B. Our value of B is 360 divided by our period, and we know that our period is 1 second. So our value of B is going to be 360. So that means that the function that I have to model this point going around the wheel is H is equal to 8 sine of 360 times T plus 11. And the value of 8, the value of A is positive because we are going towards a maximum first.